The map of 19th century naval trade provides a direct template for the insulin resistance we face today. When colonial spice monopolies pivoted to industrial sugar, they established a logistical framework that remains embedded in modern biology. Your blood sugar levels follow a path established by Victorian shipping lanes. This map illustrates the commercial routes of the era. By the 1800s, the East India Company constructed a web of shipping lanes to move luxury spices between Europe and Asia. To maximize profitability, their economic strategy shifted toward high-volume commodities like tea and sugar. This pivot transformed a maritime trading monopoly into a system that dictated how calories were produced and distributed across the globe, creating the structural origins of modern metabolic dysfunction. The Hooghly River in Calcutta served as a central hub for this trade. Ports like this were physical bottlenecks, where perishable goods often sat for months in tropical heat before they could even begin the voyage to Europe. Transporting raw, nutrient-dense food across slow steamship routes was a logistical impossibility. On a voyage lasting several months, fiber-rich whole foods would rot in the hold long before reaching their destination. The industry solved this by stripping away water, fiber, and vital nutrients. Refining sugar into a pure, dry, crystalline form created a calorie that was essentially indestructible and perfectly suited for long-term storage. This engineering requirement, extending the shelf life of cargo for the East India Company, provided the foundational template for the ultra-processed diet. Solving a 19th century supply chain problem prioritized the physical survival of cargo over human nutritional requirements, creating a biological legacy that continues to affect public health. Geographic data shows a correlation between historical colonial sugar ports and modern hotspots for metabolic disease. When we overlay Victorian shipping lanes onto a map of modern diabetes rates, the infrastructure of the past aligns with the health outcomes of the present. These legacy ports were designed to distribute refined syrups into local populations. Over a century, this infrastructure displaced localized, nutrient-dense agriculture in favor of imported, processed calories. Populations in these trade loops for generations may inherit these dietary shifts at a cellular level. Through epigenetic inheritance, the metabolic stress of a colonial diet can be passed down, modifying how genes process energy. The prevalence of metabolic disease in these regions is linked to this inherited geographic infrastructure. Human biology evolved over millennia to process the high-fiber, low-calorie diets of the Paleolithic era. The sudden arrival of the industrial maritime diet created a biological mismatch that our systems were not equipped to handle. This diagram tracks the collapse of human gut diversity. Note the narrowing funnel as we move from the agricultural era into industrial food production. Our internal bacterial ecosystems have significantly contracted in response to processed diets. These gut bacteria require microbiota-accessible carbohydrates, or MACs. As defined in this research, these are the specific fibers that fuel a protective microbial community. In industrialized populations, a diet low in MACs starves the microbiota. This prevents the production of short-chain fatty acids, which are essential for regulating human physiology and preventing systemic disease. When dietary fiber is absent, certain gut bacteria begin to consume the host's intestinal mucus lining for energy. Degradation of the mucus barrier leads to systemic inflammation, a primary driver of insulin resistance. It is the biological result of industrial train efficiency colliding with human evolutionary history. Individual dieting often fails to resolve insulin resistance because it does not address the underlying industrial supply chain. Addressing the root cause requires food sovereignty, restoring local agriculture that functions independently of historical colonial trade routes. Emerging logistical movements are now attempting to re-engineer these networks. The goal is to prioritize nutrient density and biological compatibility over the shelf life requirements of the 19th century. Reframing metabolic health involves viewing these conditions as a consequence of geographic and colonial history. Stabilizing human biological health requires replacing the maritime map of the past with a decentralized network focused on local food systems and human nutritional needs.